Welcome to this explainer. Okay, let's just dive right in. Today we're looking at a highly practical, slightly hacky, but honestly brilliantly effective pattern for testing a Go main function. Seriously, if you have ever struggled with writing tests for command line tools in Go without accidentally killing your entire test runner, you are absolutely going to love this. It's a real game changer. Part 1. Return to pragmatic Go. So, to set the stage for us, the author of our source material, Ang, recently made a return to Go. This was after spending months deep in the weeds of Haskell, and Ang was using some of the new AI coding models to refactor a long-pending pet project. Now, I absolutely had to include this quote from Ang's notes, because it establishes this incredibly fun, highly opinionated hacker mindset right out of the gate. Ang writes, "If you can tolerate the cryptic, dense nature of Perl and Haskell, you can probably tolerate anything." I mean, it's just a cheeky reminder that, every programming language has its quirks, and Go is definitely no exception. But even though Go's syntax isn't exactly Ang's absolute favorite thing in the world, they highlight exactly why developers keep coming back to it over and over. Despite those syntax quirks, Go just has some massive pragmatic perks. We're talking insanely fast compilation times, incredibly efficient concurrency through Go routines, and seamless portability. Ang rightly points out that this pragmatic, get-things-done approach makes Go a remarkably solid alternative to languages like Python, especially when you're building out command line utilities. Section 2. The main function dilemma. Okay, so let's put our problem-solving hats on for a second. Here's the central dilemma we're facing today. We're building a command line application, right? And we absolutely need to test its entry point. In Go, the main function of a console app usually wraps up by calling os.exit to return an exit status code to the operating system. You know the drill. 0 for success, 1 or higher if there's an error. But here's the massive roadblock. If your test suite calls a function that triggers os.exit, your test runner will literally terminate instantly. It just crashes the tests. You don't get a pass, you don't get a fail, the entire process just straight up dies. So how do we actually get around this? Well, the source reveals this brilliantly simple trick right on line 28 of Ang's code. It's just var osexit equals os.exit. That's literally the whole trick. Instead of calling os.exit directly inside the main function, Ang assigns the os.exit function to a dynamic package-level variable. Because functions in Go are first-class citizens, this new variable, osexit, now holds a dynamic reference pointing directly to the memory location of the actual os.exit function. Part 3. Injecting the exit dependency. Now, what's really interesting about this slide is how this variable actually solves our runtime issue. Because osexit is a dynamic variable, the Go compiler doesn't strictly lock in which function is going to be called during execution. It just knows, hey, I need to call whatever executable code happens to be sitting inside that variable at this exact millisecond. Think about the contrast here. During normal runtime production, osexit points to the real os.exit. It behaves exactly as you'd expect. But during runtime testing, we suddenly have the power to step in and reassign osexit to our very own custom mock implementation. So what does this all mean from a software design perspective? Well, the official industry term for this pattern is dependency injection, or DI. We're essentially injecting the behavior of the exit command directly into the main function. What this does is it makes our main function no longer completely reliant on a hard-coded, unchangeable system call. Instead, it depends on a variable that we completely control. Actually, scratch that. There's a really important distinction the author makes here that we need to call out. While this technically fits the broadest definition of dependency injection, it isn't your traditional DI where you're passing explicit arguments or interfaces into a constructor. Because we aren't passing arguments and we're not setting up asynchronous callbacks, what we're actually doing here is modifying global state. So functionally, this acts much more like monkey patching. We're basically hot swapping a global variable right on the fly to trick our own program. Okay, let's break down exactly how this monkey patching works in the test code, specifically spanning lines 114 to 127 in Ang's repository. Step 1. We save the original global state. That means the original arguments and our osexit pointer. Step 2. We reassign osexit to a totally fake mock function. Step 3. We actually execute the main function. And absolutely crucial here, Step 4. We restore the original state using Go's defer keyword. If you're coming to Go from other languages, defer acts just like a finally block. It essentially guarantees that our cleanup code is going to run the very millisecond our test finishes, totally regardless of what happens during the test. Section 4. The magic of closures. Now, I love this part. How does our test actually know what exit code the main function tried to send in the first place? Well, the secret to the whole shebang lies in a closure. A closure is a really special type of function that essentially remembers its environment. You can kind of think of it metaphorically as a function that has an invisible memory link to the outside world. When you create an anonymous function in Go, it doesn't just store the block of code, it literally captures and links to the surrounding variables that exist in the outer scope. Let's walk through the specific 3-step visual code breakdown that Aang provides to kind of demystify this magic. In our test, step 1, we declare an outer variable and call it exit code. Step 2, we create our anonymous mock function and assign it to OS_exit. And step 3, inside that anonymous function, we literally just say exit code equals code. Because it's a closure, it reaches right outside of its own boundaries and modifies that integer we defined back in step 1. So when the main function calls our fake exit function, it silently writes the exit code to our test variable instead of killing the entire program. It's kind of brilliant. And this just brilliantly illustrates the sheer elegance of Go's type system. But there is a very crucial technical caveat that you absolutely have to remember here. The mock function we write can't just be any random function. It must flawlessly mimic the original function's signature. Since os.exit takes an integer, our anonymous mock function must also have the exact same type signature of funcint. If it doesn't match perfectly, the compiler is going to throw an error at you immediately.
Section 5. Trade-offs and pragmatism.
So you might be wondering, why would a developer consciously choose this hacky pattern over something a bit more robust? Well, every engineering decision has trade-offs, right? On the downside, this technique modifies global state, which means it will absolutely break parallel test execution. If you have 2 tests running at the exact same time, and they both try to monkey patch OS exit, you are going to end up with a highly chaotic race condition. However, as the author summarizes, for a small console application, this approach is perfectly fine. It gives you 100% test coverage on your main entry point while avoiding the trap of drastically over-engineering your entire codebase just to satisfy a test runner. It's really all about pragmatism over purity.
Which leaves us with a really provocative final thought to reflect on today. In your own projects, is technical purity always worth the cost of over-engineering, or is a simple monkey patch sometimes the absolute perfect solution? It's definitely a great question to ask yourself the next time you find yourself stuck on a tricky test. Thank you so much for joining me for this explainer today. I really hope this gave you a clear, structured understanding of testing the Go main function. Keep building, keep learning, and I'll catch you on the next one.